Okay, welcome back. We are now going to be doing problem 8, logarithmic functions graphing. Okay, so the last problem we did had a base of a 2 or a 3, right? So if you take a 2 and you have, it's 2 to the x power, and you increase that x, 1, 2, 3, 4, 5, that's going to be 2, Okay, 2 times 2 times 2 times 2 times 2. That number's going to keep getting bigger, right? However, if you have a value between, the absolute value of the number is between 0 and 1, like this number, our base is 1/2. Okay. What happens when you take 1/2 and you keep multiplying it by, you have an exponent to the x power, and you make that a 1, and then a 2, and then a 3, and then a 4, and then a 5. It's going to be 1/2 times 1/2 times 1/2 times 1. What happens? What's 1/2 times 1/2?
1/4.
1/4. It's smaller.
Yes.
So as we increase this exponent, the y values are going to keep getting smaller. Okay, so over here, if I use my original points, if I'm thinking the base is 1/2, and it's just parent function y equals 1/2 to the x power. If I plug in 0 for the exponent, I'm still going to get 1, because anytime anything to the 0 power is 1, right? So now, if I plug in 1 here, 1/2 to the 1 power is 1/2, and I can easily plot 1/1/2. But usually, if we have a base, it's a fraction, we use -1. Because, as we just learned about in our review from radicals, what's 1/2 to the -1 power?
1/2 to the negative. Oh, that would change it to
1/2
That would put the 2
to the -1 power is equal to
2.
2. Much easier to graph. So, and that's in my notes, but I think it'll probably be easier for you to understand now. If I plug in -1, I'm going to get 2. That point's easier to graph than 1/1/2. So that's just what we do. So, these 2 points, 0, 1, it's going to go somewhere after I multiply it by that a, and -1, 2 is going to go somewhere after I multiply by the a. In this case, the a is 5. So those y values are going to be multiplied by 5. So 0, 1 is going to go to 0, 5. And -1, 2 is going to go to -1, 10. Are you with me? Now, you can choose to plot those points if you'd like. Let's plot it. We'll just follow the same pattern as the last one we did. -1, 10. So notice what's happening here. So here's your asymptote. Right there. The original parent function is at y equals 0, right? This one has gone down 4. Okay, and we're going to move those points around. But right now, with the asymptote at 0, this graph is going this direction, and that's called decay. Because as the x values are getting larger, the y values are getting smaller, and the graph is approaching the asymptote. That's called converging. Okay, but we have something else going on in this problem, and we've got. I'm going to rewrite this exponent as -x. -x minus 3, because if I distribute that negative, it's a -x, and then a -3 makes it +3. What happens is, what this says is we have a negative in our exponent, which is going to be a reflection over the y-axis, and we have a horizontal shift of 3 to the right. So in our last problem, we had a leading coefficient that was negative, so our graph went from up and then it reflected over the x-axis to down, right? And now we have a negative exponent, which is going to take our graph, it's going like this, and it's going to reflect it over the y-axis, and it's going to go like that. So, all right, different color. So we've already taken care of the A. All we have to do now is reflect over the y-axis, and then we're gonna move it right 3 and then down 4. Good? Okay, so, boom. When you're reflecting over the y-axis, this point should stay in the same place. I hope I don't make a mistake here and have to delete my... So, there we go. That one's gonna stay in the same place, and then we're gonna go right 3 and then down 4. Take my X, gotta X them out, just so I know those are not my actual points. Right 3, 1, 2, 3, down 1, 2, 3, 4. Right 3, 1, 2, wait, 1, 2, 3, 1, 2, 3, 4. All right, let me check my graph. Looks good. Ain't that party? What do you guys think of this graphing?
Easy. It's just like.
All right, domain, same. Range should be getting easier, right? Where's the graph? Where are the y values? From looks like -4 to infinity. Our asymptote is at y equals -4. And this one, our original function before we reflected it was converging, but this one's actually diverging. Because as the x values get larger, what happens to the y values? This graph is not approaching the asymptote. All right, I think my video's way too long.